this is your host Simplifies, and welcome to another episode TFR Let's Talk. And today we have with us Nati Shalom, CTO and founder of Cloudify. Nati, it's good to have you on the show.
Thank you very much. I'm glad to be on the show. I've read a lot about you and the show, and I must admit that I really enjoy following up all the content that you guys are delivering. So I'm excited to be here.
And I'm equally excited to have you on the show. This is the first time we are talking to each other. So I would love to know a bit more about the company since you're the founder. What is specific problem you're trying to solve that you created the company? So tell me the story of the company.
Sounds good. I'll start with maybe a quick introduction of myself. As you mentioned, I'm the CTO and founder of Cloudify, previously Gigaspaces. And kind of the background is that what excites me is really the intersection between technology and business. And in general, as we probably know, open source and cloud really introduces a lot of opportunities in this regard. And in that context, I'm really actively pursuing a lot of thought leadership type of activities, podcasting, etc. I also find all the complexity of dealing with highly distributed system quite fascinating. And that's kind of explains the background that I had also with Gigaspaces, starting with NoSQL, grid computing, HPC, and now it's multi-cloud, edge, and what we're going to talk about is environment as a service, which is kind of the next generation of DevOps in my view. And really, it's all about how to drive new innovation and making a lot of those distributed systems as simple as local system. That's, I would say, in a nutshell, the type of things that drives a lot of the ideas that I'm working on through my career, and also a lot of the innovation that I'm working on with strategic partners such as AWS, ServiceNow, Wind River, VMware, etc.
Excellent. Thanks for sharing that background. Now, you use the term in the environment as service. Today, we do look at most of things as service, and the goal is to make it easier, lower the barrier of entry for companies so they can quickly jump in there. Otherwise, if they have to do everything themselves, it will take them years to get up and running. So, talk about how do you define environment as service, and I think you also call it version 2.0. So, let's start with what it is and how do you see the next generation of it?
Yeah, so maybe again, a quick background of how we came with the term. So I think when we started the terms of orchestration and automation, I would say that generation one was really about moving manual processes into an automated processes. So a lot of the focus was really done around that. Fast forward 2020, 2021, we're now in a point in time in which there is no short of automation. Everyone, I think, understand the concept of automation. And we're actually at the point in which we have too many automation. A lot of that is driven from the fact that we actually need faster time to value. And therefore, we find that having one automation to rule them all isn't enough. And therefore, we're going to see a lot of those specialized automation that are specific to each problems. And we're now seeing more of that coming along with DevSecOps, with MLOps and now FinOps. And that kind of list grows and grows. Environment as a service is really, environment as a service 2.0, I would say, is really positioned into that world where we have a lot of automation tools, where we have a lot of automation templates. People have started the journey with Kubernetes and Terraform as part of that, but finding themselves now dealing with a lot of Kubernetes clusters and a lot of Terraform templates, and are looking a way to solve a lot of that complexity. Traditionally, what happened is that they put DevOps into that problem. So what we found is that a lot of those teams was writing a lot of the glue code to integrate all those automation tools, building automation around their environment through a lot of custom work. And obviously, as system grows and scale, that doesn't scale. And that's kind of how the concept of environment as a service came along, just to provide kind of a built-in solution rather than doing a lot of that custom integration.
Now let's talk about the company and its offerings so that we can also understand when you do talk about, environment as a service, how do you actually help? So talk about what kind of, offerings you have for your users and customers.
Yeah, so let's use a use case, and I think that helps to explain the concept. So think about development and production that everyone has. In most of the development production system, you'd have Kubernetes, you'd have Terraform, you'd have database, you'd have networking. And the production environment would have requirements to deliver everything in a highly available session because we optimized for availability and scalability. Development environment, on the other hand, have very different requirements. They would use the same stack, but We want it to be completely isolated. We want it to run it very fast and roll it very fast so that we can run a lot of tests around those type of environments. And we also want to optimize it for cost because a lot of the resources doesn't have to be redundant. We just need the API endpoint. We don't really care if it's highly available or not for the testing period. So those are two, I would say, very interesting example of the same, if you like, environment, but with very different needs for per environment. And right now, managing a lot of those variation of this type of environment, and it could be development and production, but it could also be different products. It could also be between the same environment between different customers that we're serving in our SaaS environments. There's a lot of cases in which we have almost the same thing, but it needs to behave and provide different behavior around that. That leads to a lot of complexity, because when we have this variation, that really means that we're duplicating a lot of the work. We're duplicating a lot of the maintenance work. We're duplicating a lot of the configuration work, a lot of the high availability work, and that leads organization to really run in a highly, I would say, in an environment that is far less optimized because of that complexity. Environment as a service is really all about decoupling the infrastructure from the workload and allowing organization to do the dynamic matchmaking between the right infrastructure and the job. And that's kind of the whole concept behind it. So the idea is that if we can decouple it, we can now, one, simplify. So we can have the dev environment as one environment and the production environment as one environment. And it would be dynamically adjustable to fit the SLA of development when we're running it in development, and would run, if you'd like, the stack in a single instance mode, for example, or it would be optimized for production. If we're running it in production, the developer that is running workload against this environment doesn't need to be exposed to all those differences. So the whole idea of that environment as a service is really through that decoupling to provide the right infrastructure for the job and simplifying how this matchmaking is happening behind the scenes. It is an open source product. It's an open source orchestration product. And it's actually running today in very, I would say, highly demanding type of environments in enterprise and software companies. It's in production for a couple of years already, running a lot of those, like the AT&T of the world, the Morgan Stanley of the world, the TD Bank of the world, a lot of those type of organization. We interestingly enough, starting to hit the scale-out companies that are web scale type of companies, which are software vendors. And that's, I would say, the next wave of adoption of Cloudify that we're seeing right now in the market.
Now, I'll go back to the point that you were making about Kubernetes, and things get complicated very quickly. And I think by design, you cannot avoid complications when you're talking about Cloud Native or Kubernetes. And that's when you also kind of talk about, look at it as orchestrator of orchestrators. I want to, once again, it feels like trying to simplify and make things easier for users. So try explain what do you really mean there? And of course, you alluded to how you're helping them, but let's talk about that.
Yeah. So again, let's start with a real use case. Usually, when you started the journey with Cloud Native and Terraform and infrastructure as code, you'd start with few templates and with single Kubernetes cluster. Very quickly, you get to the point where you have multiple Kubernetes clusters and many Terraform templates and many other templates that you already have and scripts, etc. So the first thing is really, and what the organization have done, they put DevOps into the problem. So they put people to actually write glue code. Glue code meaning, how do I take this Terraform template and Kubernetes cluster and move workload here and move workload here, run it in a pipeline for this use case and this use case. A lot of the glue code is done in a way that is very proprietary to one use case. And once you need to make changes to that glue code, that's where things become very complex, because it's like a spaghetti. What environment as a service really does is we provide a lot of that integration with Kubernetes, with Terraform, with Ansible, with CloudFormation, with Azure Arm. A lot of that integration is out of the box. So we have building blocks that we've already invested in, and you don't have to write this integration yourself. That I would say number one. And second, we allow you to organize it in a templatized environment, so the entire environment has a state behind it, and we can therefore manage update scenario in a much simplified and generic way. So instead of update being going to a pipeline and changing a script, update being just running an operation that says, oh, just add another component into the system, add another firewall, change configuration. It will know how to deal with that delta and apply it to the end-to-end environment to reach the end state of what you're looking at.
Now, I want to just quickly change topic and talk about some of the use cases you're mentioning, and it's something that we cover closely at TFR as well, and it's personally interest to me as well, which is 5G. I want to understand from your perspective, what is the role of communication service providers or CSPs in the 5G rollout? And also last year, if you remember, the US government, they released some spectrum CSP so that kind of further democratize 5G rollout as well. So talk about that, and of course the role of CSPs there.
The things that you mentioned about 5G, people think about 5G as a better version of 4G, but you touched on something that I think is fundamentally different, which is called private 5G, which is think about it as a better version of Wi-Fi. And second, it's something that is called network slicing, which means that instead of having one network that is shared between everyone, you could attach or adjust the network to fit specific users. The relevant to Cloudify is that it, at the end of the day, leads to a highly complex and dynamic type of network that, unlike any other distributed system, requires a lot of that automation that previously was done kind of half manual, semi-manual, and things of that line. With 5G, CSPs are now forced to do two major things that are very different to their nature, if you like. One of them is have everything fully automated and kind of forget about a lot of those manual work. And second, also collaborate with public cloud to support those private 5G, because they also need to collaborate not just for getting the scale in the infrastructure, but also to allow them to get the mind share of developers into that. And that's kind of changed a lot of the dynamics. And in my view, the change is really similar or analogous to the change that we've seen between Netflix and Blockbuster. If you recall the analogy, Netflix realized that the change that is happening into the media company, the media vertical, is so dramatic, so they kind of moved public cloud and they adopted a lot of the DevOps practices quite aggressively, where Blockbuster were kind of left behind, and we all know where each one of them ends. So I think that the role of CSPs is kind of getting to a very similar type of point, intersection point, to the one of Netflix and Blockbuster in that regard.
Now, I will talk a bit about a recent podcast that you folks did with Martin Casado, and it was an interesting podcast up there on the site. It was about the $1 trillion paradox, and where you kind of argued about that the focus on cloud optimization instead of repatriation, that is an ideal case. So I want to understand your. I mean, of course, people can go and listen to the podcast and also read the whole transcript there, but I want to hear your views on that, to just go a bit deeper into that podcast.
Yeah, definitely. So I think Martin Casado, he called it in the podcast Cloud War 1.0 versus Cloud War 2.0, which I kind of liked. The idea of Cloud Wars 1.0 was really cloud providers seeing the check that they need to pay to hardware vendors like Dell and HP, etc. And the point in which it reached that 50% of their total, revenue, they reached the point of the conclusion that they have to look at the full supply chain and optimize that stack, and there is no way they can pay and can afford paying such amount to a supplier, a single supplier. And that's kind of how they started to run their own hardware venture, if you would like, which at that time, that was 10 years ago, at that time, it looked almost insane. I think we all look at that backward, and I think that looks much more sensible than it was back then. He points to a similar trend that is happening right now with hyperscale software vendors, where what he points out right now is that instead of hardware vendors, it become the cloud providers, the equivalent of those hardware vendors. SaaS providers now pay almost 50% of their revenue or even more to public cloud providers because of the lack of efficiency. And he was starting to point on Spotify, Dropbox, and other companies that have got to the point where, similar to what cloud providers did in the past, to take their supply chain, find out how much they're spending on public cloud and say, okay, we'll repatriate some of that workload. By repatriate, we'll take some of that workload outside of the cloud and manage it in a much more optimized stack ourselves, because it's very special. It doesn't mean that they moved everything into their private cloud. It means that they took the workload that is, I would say, highly sensitive to cost and is very special in terms of its usage. It's not a generic workload, and obviously have impact on cost if they repatriate it. And that's the part that they started to optimize. My argument there is that if you really look at the argument, it talks about efficiency in more general terms, and how much companies are not really putting attention to efficiency because they're very much focused on velocity, meaning adding more features, new product. They're very much incentivized and not being measured on how well, not just how they grow and add more customers and features and products, but also how they keep their margin high. And I think he points to that in what he called Cloud War 2.0. And I kind of took that point and generalized it and says, it's not just repatriation. Repatriation is one option to get to that level of optimization. There's much more into it. Even if you look at Amazon itself, there is 400 VMs of EC2, 400 options to run EC2 on Amazon itself, let alone Azure and other clouds. There is many different platforms to run the same workload, ECS, EKS. We now have Lambda services, and the list grows on and on and on and on. And if you look at efficiency from that angle, even within the same cloud, even if we don't really repatriate, there's a lot of options that most organizations don't have a clue how to deal with that. And the main lesson there is that it's one, you have to gain that practice, especially when you reach that scale. And second, it's a continuous engineering work that you have to be prepared to put resources and effort around it. It's not like you're going to throw a tool there that's going to do some magic and optimize all of a sudden what you're doing. It's going to be a lot of engineering work, and you have to prioritize it in the same way that you're prioritizing other product features, customers. And it has to be higher in the priority list of most of those companies than it is right now.
If you look at edge use case, that's where we talk more about hardware. Plus, when I look at cloud native, I look at it more of a process of way of doing thing versus a thing itself. You can have a purely cloud native environment in your data center as well. But going back to the point of hardware, how do you look at edge use case? Because that's where developers have to deal with hardware, because sitting in some remote location there, you can, of course, orchestrate it using Kubernetes. But from Cloudify's perspective, how do you look at that? Because that's where we're talking about bare metal.
Yes. So I think that that's actually interesting, because we usually think of edge as, network use case. But now if you look at a lot of security companies, you see that a lot of security companies now have to put a lot of point of presence, that is called POPs, around the globe for latency. Think of the Zscaler type of scenario and things of that line. So, and there's a lot of use cases where you would need that low latency access, where edge becomes a good practice. Now, there are a couple of things that drives that hardware type of optimization. One of them is cost. So obviously, a lot of the edge, when you get to that volume of the number of instances that you have, whether it's for content delivery network and whether it's for those POP instances, you're talking usually about thousands of instances that you have to manage. And obviously, if you could optimize every element there, the gain in terms of cost becomes substantial. And in many cases, you could optimize it, because you're not looking for something generic, you're looking for something very specific, and there's a lot of way to optimize it. And so that's kind of the business case of going in that route when it comes to edge. The other thing that I think is important when it comes to edge is the fact that it's in many cases running on somewhere else environment, not necessarily in just the cloud. And because of that, there's going to be some if you like, placement and other type of things that needs to be done in terms of provisioning and managing that provisioning. That I think also drives the thinking of edge as a separate use case, or as a different use case than I would say other workloads that are running in the cloud. That's from, I would say, the use case itself. Now, from a management perspective, we actually take a very different view, in which we want to look at edge as just another compute instance in the cloud. And why is that? Because we want simplicity. We don't want complexity. if we look at Edge as yet another compute instance in the cloud, then we can apply the same practices, tools that we have in the cloud, and Edge becomes just another compute instance. So there's this, if you like, interesting contention between having specialized kind of use case of Edge for optimizing it for efficiency and cost versus simplifying and managing it in a simplified way where you want to look at Edge as just another compute. And that's kind of, I would say, my view on that.
Excellent. Nati, thank you so much for taking time out today and talk about Cloudify environment service and other points. Thanks for those insights. And as I said, I would love to have you back on the show. Thank you.
Thank you very much.